Have you ever wondered how bridges are built, the magnificent structures that connect places and facilitate our journeys? These architectural marvels are much more than just pathways over obstacles. They are a testament to human ingenuity and perseverance. Bridges are crucial to our daily lives. They allow us to cross vast bodies of water, navigate around towering mountains, and traverse deep valleys, all while keeping us safe and making our journeys more efficient. But have you ever stopped to consider the intricate process that goes into their construction? From the planning phase to the final touches, each step in the creation of a bridge is a complex dance of engineering, architecture, and construction. It's a process that requires meticulous precision, a deep understanding of materials and their properties, and an unwavering commitment to safety. By the end of this video, you'll understand the key steps and elements behind the creation of these architectural wonders. Like any great endeavor, bridge construction begins with meticulous planning. The planning phase is the backbone of bridge construction, the bedrock upon which every subsequent step firmly stands. Without a well-thought-out plan, bridges, these architectural marvels that span valleys and rivers, would be mere fantasies. First up is the location. A bridge isn't just thrown casually across any gap. Engineers must carefully assess the terrain, the soil type, the weather conditions, and even the seismic activity of the area. They have to consider the purpose of the bridge too. Is it for pedestrians, vehicles, or trains? Each purpose calls for a different design and different materials. Next, engineers must decide on the type of bridge. From arch and beam bridges to suspension and cantilever bridges, each type has its own strengths and weaknesses. The choice depends on a range of factors including the distance to be spanned, the load it must carry, and the conditions of the location. Materials come next: steel, concrete, wood, or a combination. The material chosen for a bridge must not only be strong and durable, but also suitable for the environment. For example, in a salty coastal area, corrosion-resistant materials would be the way to go. The planning phase also involves an in-depth look at the potential environmental impact. Engineers must ensure that the construction and existence of the bridge won't adversely affect local wildlife or ecosystems. This could involve conducting environmental impact assessments and taking measures to minimize any negative effects. Budget is another crucial aspect. Constructing a bridge is a significant financial undertaking. Every aspect from labor and materials to maintenance costs must be factored into the budget to ensure the project is financially feasible. And finally, with all these considerations in mind, engineers and architects create detailed blueprints. These blueprints serve as a roadmap for the construction team, outlining every single step of the construction process. With a solid plan in place, the construction team can now move on to the next phase. After planning, the next step is laying the foundation, the bedrock of any bridge. Imagine the foundation as the roots of a tree, deeply embedded, holding the structure firm against the elements. This is essential for the bridge that has to withstand loads and forces of nature. The process begins with driving piles into the riverbed or seabed. These piles, usually made of steel, concrete, or wood, are hammered deep into the ground until they reach a layer of soil or rock strong enough to support the bridge. This is the literal groundwork, the unsung hero of the bridge's lifespan. Next, we create piers. Piers are robust vertical structures that serve as the intermediary between the foundation and the bridge deck. They are constructed over the piles and often extend above the water surface, acting as a steadfast support for the bridge's body. Ensuring everything is level and sturdy is a vital step. This is where surveyors step in, employing their tools and expertise to guarantee the foundation is solid, level, and correctly aligned. Any misalignment or instability at this stage can lead to significant issues down the line. The importance of a strong foundation cannot be overstated. It ensures the longevity of the bridge and, more importantly, the safety of those who will traverse it. It's the silent, unseen hero that bears the weight of the world above. A solid foundation sets the stage for the construction of the superstructure. With the foundation in place, it's time to erect the superstructure, the visible part of the bridge that we drive or walk on. The superstructure is a marvel of engineering, a testament to the ingenuity of human design. It consists of various components, each with its unique role. Beams, girders, and trusses are the backbone of the superstructure. Together they form the deck, the flat surface where vehicles and pedestrians tread. Beams are usually made of steel or concrete and span from one support to another. Girders are larger versions of beams and are used to bear heavier loads. Trusses, on the other hand, are triangular frameworks that distribute weight evenly, providing the deck with the stability it needs. But what about suspension bridges, you might ask? These architectural wonders use cables and towers in their superstructure. The towers rise high above the deck, while the cables hang from the towers and hold the deck up. This design allows for significantly longer spans than traditional beam and girder bridges. Materials for the superstructure can vary, but steel and concrete are most common due to their strength and durability. However, the choice of material ultimately depends on the bridge's design, purpose, and location. Each part, from the smallest bolt to the largest girder, plays a crucial role in the bridge's strength. They work in harmony to distribute weight and withstand the forces of nature, ensuring our safe passage from one side to the other. The construction of the superstructure is the final step in the creation of a bridge. So, there you have it, the fascinating process behind bridge construction. It's a journey that begins with meticulous planning where every detail, down to the last bolt, is painstakingly considered. The architects and engineers sketch, calculate, and model, ensuring the bridge can withstand its environment and serve its intended purpose. Then, we move to the foundation phase, a cornerstone of any successful bridge. Immovable and solid, it's the bedrock that supports the enormous weight of the structure above. It's laid with precision, often deep beneath the water surface, to ensure stability and longevity. The final stage is the erection of the superstructure. This is where the bridge truly starts to take shape. Steel, concrete, cables, all assembled with intricate care, forming the backbone of the bridge. It's a testament to human ingenuity, a physical manifestation of our ability to overcome obstacles and connect landscapes. Next time you cross a bridge, remember the intricate process that went into creating it. It truly is a marvel of human ingenuity and engineering.